I like big boats, and I cannot lie, and this boat is one of the biggest in the world. Let's talk about this RC submarine, what it looks like, how it works, and most importantly, how it did on the water during its maiden voyage. So what you see before you here is a 1/96th scale example of the US Ohio-Class Submarine, which is to date, as far as I know, the third largest submarine in the world behind the Russian Typhoon and the Russian Bory-class submarines. It's not to say it's a slouch in terms of size. It's over 570 feet in length, sporting over 22 vertical missile tubes, each one of which carrying 7 Tomahawk missiles, so it can lay down some pretty serious firepower. This boat was manufactured by a company called Sheerline out of the UK, and they've been around, or were around, since the 90s. I'm going to guess that this particular boat was probably mastered in that area, but this is a fairly new boat. To the best of our knowledge, I don't think it ever saw the water until we finished it out just a few days ago, and today saw its maiden voyage. I want to show you what this boat looks like inside, but before we get to that, let's talk about the boat a little bit in detail. So the US Ohio-Class was laid down in April 1976, and it was launched in April of 79, delivered in October of 1981. It'll supposedly do 12 knots surfaced. The official speed submerged is 20 knots, but there's been reports of over 25 knots submerged. I don't think anybody except those serving on her will actually know. Armament, as I said, there's 22 vertical missile tubes, each one with 7 Tomahawks, 154 altogether. Because this model is 1/96-ish scale, we're looking at a 68-inch overall length for this model. Now, as you can see, this is not an exceptionally detailed model. I think Sheerline was probably doing the best that they could with the research resource that they had available at the time. I would call it a standoff scale. And they've done some interesting things to the boat from a command and control perspective that make it a little bit easier to operate, but also deviate from the original. Let's take a look at some of the most important. So the first thing that we see here are some oversized fair water planes. These are mounted in the sail, as was the wont of the United States Navy at this point in history. They have since seemed to move to bow-mounted dive planes. So this is very indicative of this era of submarine. Like I said, these are a little oversized, so they look not quite as scale, but they do offer superior control of depth. Moving to the back, the other big thing that we can see back here is there are no separate dive planes, rear dive planes in these stabilizers. The way that this is set up, the entire rear fin assembly tilts forward and back. And again, while that isn't purely scale in appearance, it does offer very superior pitch control for the boat. Taking a look at the hull, you can see some really interesting, design in here. They're not really anechoic tiles, but they do have some grid work that's been etched into the fiberglass hull, and that just lends it a little bit more interest when you take a look at it. All right, now that we've taken a look at the outside of the boat, it's time to take a look at the inside. Two things that you need to look at when you're getting access to this boat. There is a forward screw and an aft screw. The aft bolt is stainless steel, and it is a separate bolt. There's a little hole in the stand right here that you can put that bolt in so you don't lose it. So that comes right out, but in the bow, there's actually an enclosed bolt that does not remove, but it does unscrew, and that's accessed through this hole right here. Once you remove those, you can lift the entire upper hull off. Now, before I do, you take a look at the back here where my finger is. You've got a linkage for that upper rudder. It's a little hooked linkage, and that hooks into the lower rudder linkage. If I pop that off, now the entire hull can lift free. And we've got access to the interior of the boat. Now everything is wet because we literally just got back from her maiden voyage a few minutes ago. Let's start at the back. Got a nice brass propeller in here, not 100% scale in terms of appearance, but it gives some really excellent performance, as you will see in a few moments when we take a look at the video. Here's that tilting rear dive plane assembly that I was talking about before. So the whole thing moves up and down. And then we got the same thing for the rudder. We got our lower rudder here, and that hooks up to the upper rudder through this little linkage connector at that point. Got a universal joint that runs into a dog bone that runs into our motor output. We've got some magnetic connectors in here, and the combination of the dog bone and the magnetic connectors here means that installation and removal of the cylinder is exceptionally quick and easy. Now we take a look at this Sheerline watertight cylinder. Clear acrylic end caps that are like 1/4 of an inch thick. They're absolutely massive. And they've got some integrated seals that are created with some RTV in there. The way that this seals, these long stainless shafts have nuts on the end, and they compress these end caps against the tube, and that is where your seal is created. Up at the front here, we've got some power connections. We got our positive connection, and that's all been waterproofed, which is really cool. This is how you turn the boat on and off. You just simply connect it, and the boat powers up. We've got our negative connection on a nut here. And then this is the waterproof connection for the fair water planes. And I want to show that to you right now. So rather than having a servo in the forward dry compartment, it's a waterproof servo that's mounted directly in the sail. So if you take a look there, you can see a blue servo, and that's connected directly to the linkage for those fair water planes. Makes an exceptionally positive connection. With some really good control over the fine pitch of those fair water planes. And again, this is all waterproof connection directly into the cylinder. All right, before you go to the pond, obviously you want to test all of the functions of the boat, and I want to share with you how everything works inside so you can see it all working. First thing to do, turn the transmitter on to make sure that our throttle is centered. We've got good voltage on the battery, and we just connect power. So now everything is basically connected here, and it's fully operational. So let's start at the bow, and we'll work our way back. Again, that really positive throw on the fair water planes. And then we've got our ballast control. And the way that this works inside, and I don't have this opened up for you, but basically there's a windshield washer pump. Draws water in through here and pumps it into the sealed ballast tank. And after a while, what'll end up happening, that flow will become slower and slower until the flow or the pressure that pump is able to put out can't overcome the air pressure inside the ballast tank, and it stops filling. Turn the pump off, and a servo swings into place, crimps off the filler hose, and that's what stops the water from backflowing. To surface, that servo simply opens up, and the air pressure inside blows all the water from the ballast tank back out that hole, and the model surfaces again. So you'll be able to see here to dive. We'll turn the pump on, you'll hear it. I'm not going to run it for long because it does need water. So that's the pump, and then you can hear the servo working for the vent. And that's it. Super simple, but really quite effective. The only downside to this system that I can see is if for whatever reason you have a leak in this sealed ballast tank, you're going to lose pressure inside. If you lose pressure inside, you're not going to be able to blow ballast back out. Now, the odds of that happening are pretty slim. This is a completely sealed ballast tank. There's only one exit, and that goes out to the pump. So the odds of having a leak are pretty low. But again, if you lose pressure for whatever reason, you won't have the ability to blow ballast again. Just something to think about. Shooting to the back here, we've got our standard controls. We've got our rudder set up. We've got the override for the stern planes. And these are all set up on an exceptionally sensitive pitch controller. So that automatically maintains the pitch of the boat. Now the way I've got this set up, that pitch is on this rear proportional channel. So in practical application, when you're running the boat, you can dive it so that it's at submerged trim with just the tip of that sail sticking out. And as you go, if you notice a nose up or a nose down attitude, you can tweak that just with your pitch control, and that'll kind of recenter your pitch control. It makes it so that basically you can get hands-off operation of this boat at periscope, and you're going to see that in a few minutes when we are at the pond. All right, last thing here is the throttle, and nice and smooth and quiet. It's actually pretty beautiful. I was a little skeptical at first because the motor is literally about this big, and typically I'm used to seeing a direct drive, big, monstrous brushless motor. This is a smaller motor, high RPM, that's running through a mechanical gearbox. So it's actually a geared motor that's geared down probably 3-to-1. So you take those super high RPMs, drop it back down, and that gives you just a beautiful slow control over the propeller, and it's just nice and smooth and quiet. I'm really impressed with it, actually. It turned out really cool. So that's it. That's the internal workings of the boat. The only other thing that I did not touch on was this antenna, and that goes up in this highest mast here. This is the 2.4 gigahertz antenna, and it just rests right there. It's disguised as a mast or periscope in the boat. Very, very easy to keep this boat at periscope depth, and you've got a lot of wiggle room to play in for depth in there. And to that point, again, it's a 2.4 gigahertz boat. You do not want to dive below the level of the antenna because the receiver will lose communication with the transmitter and it will go into fail-safe mode. I want to show you what that looks like. So if the boat can't communicate with the transmitter, it doesn't know what you want it to do, so it's going to go into like panic mode, and it's going to try and get back up to the surface as quickly as possible in order to regain your signal. And the way that I have it set up, and this is completely customizable by the owner, the way I have it set up, forward planes go to full rise, stern planes go to full rise, throttle goes to 0, and the ballast tank blows. So basically, it's all out to get it back up to the surface again to regain. So I'm just going to test that. We'll pretend we're cruising along at periscope depth. This is about 1/3 throttle, for example, and we're going to fake an inadvertent dive underneath the water. The antenna goes underneath, and we're going to turn the transmitter off, and almost instantly, we should see everything move. Full rise, full stop, and the internal servo inside went to vent. So in theory, hopefully, the model resurfaces, gets the signal back. We'll fake that by turning the transmitter back on again. A few seconds later, we're right back to where we left off before we lost signal. It's a cool setup, and another reason that I love the 2.4 gigahertz radios. So I'm going to show you how to take the cylinder out. Obviously, to put the cylinder back in again is just the complete opposite of what I'm about to show you. We're going to start by disconnecting the forward dive planes, the fair water planes. Those come out. We've already disconnected power. Now we're going to take the negative lead off of the stud here. And we're going to want to make sure that once we do, we put that nut back on so it doesn't get lost. Going to the back, we're going to disconnect our magnetic linkages, which might actually be tricky because they like to snap back into place. Grab the cylinder. I'm going to undo our Velcro here before I forget. There, now we're going to grab our cylinder, just lift up, drive shaft pops off, grab her up by the front, and this is it. This is our watertight cylinder. It's been removed. You get access to it by these 4 nuts in the front there, and you can slide out your equipment trays and do all of your maintenance and everything in there. Looking inside the boat, what we've got here is our main drive battery. This is a nickel metal hydride battery pack, 12 volts, and it's been completely sealed with a heavy duty heat shrink. You can see the 2 sides are sealed. You pull these wires out from underneath that forward bulkhead, and these are all sealed as well. So you charge this using the nickel metal hydride settings on your computerized battery charger, which everybody has, of course. And that leaves us inside here, so you can just see the mounting bulkheads for the cylinder and the hold down Velcro tabs, drain holes, and this is all of the ballast weight that went into it to get the boat at the proper trim. This cylinder obviously is huge. It's about 4 inches in diameter, and I'm going to say roughly 30 inches in overall length. That's a lot of buoyancy, so you need a lot of ballast to get the boat down to the proper water line. So there you go, an overview of this 196-ish US Ohio-Class, actually the actual USS Ohio from Sheerline. This was originally built by Ken Griffin in Florida. I don't think it was ever completed. We did all of that. We did some work to the cylinder, increased its reliability a little bit more, and set it up with that 2.4 gigahertz radio. Tested, trimmed, and brought it to the lake, which brings us to the next section of the video, which is what you were really waiting to see, the lake trials. Just a few notes from the lake. Surface turning performance is abysmal. I'm going to say that was probably something to the effect of like a 40-foot diameter circle to turn the boat in full surface trim, but that drops in half when you get the boat submerged. And that makes sense because in surface trim, half of the rudder is not in the water. So when it's submerged, you got twice the rudder area and twice the turning performance. The boat will also get up and move really, really well. It's got a really good turn of speed. The biggest thing though, as you'll see, it holds, dives and holds periscope depth rock solid once you have it set up properly with your transmitter, hands off. Beautiful running boat. It was a ton of fun to operate at the pond. We got a lot of comments from people around at how cool it was to see. If you like what you see, please do like and subscribe. It helps me out a lot. I am Bob Martin, the RCSubGuy with the NautilusDryDocks.com. Thank you for joining me, and we will catch you next time.